All right, so this is an ALEKS topic that's called stoichiometry limiting reactants, and this is a requested video, so thank you, Madeline, for the request. So in this problem, we're going to have to start with a balanced chemical equation. So we're going to take the information that's given, write a balanced chemical equation. Then we're going to do a limiting reactant discussion, and then based off of our limiting reactant, we're going to use stoichiometry to solve the problem. So let's go ahead and get started. The first thing that we're going to want to do, like I said, is write a balanced chemical equation. So I'm going to take the words that are given, HCl, aqueous. So we don't really need to use these phase labels right now, but I think it's a good practice. So aqueous HCl will react with solid sodium hydroxide to produce aqueous sodium chloride. So that means dissolved in water, plus liquid water. So we're going to form some water in this reaction as well. But since it's HCl is aqueous, that sort of means that the reaction is done in a bunch of water, so there's going to be plenty of water, H2O liquid. We're told that 34 grams of hydrochloric acid is mixed with 47.0 grams of sodium hydroxide, and then we're asked to calculate how much of the sodium chloride will be formed under these conditions. If you actually did this experiment and you mix these two things together, how much of the sodium chloride would you actually form? So the first step, we're going to convert from grams into moles. Anytime we're doing limiting reactant or stoichiometry, we really need to be talking in terms of moles, because that's really what a balanced chemical reaction is telling us. It's telling us 1 mole of HCl will react with 1 mole of sodium hydroxide to give us 1 mole of sodium chloride and 1 mole of H2O. We're not showing the coefficients here, but if we did have 2s and 3s or whatever, those are in terms of moles. So we always want to make sure we're working in terms of moles whenever we're doing limiting reactant or stoichiometry problems. So a lot of converting between grams and moles in these problems. In this video, I'm going to just be doing this problem, but I'll do another video that's a slightly more complicated one where we'll have to take into account, coefficients essentially. But for this one, it's just a 1-to-1 ratio, so it's a little simpler. So convert grams to moles, 34 grams of HCl times 1 mole over 36.46 grams. That's just the molar mass of HCl. So 1 mole of HCl will weigh 36.46 grams, just using the periodic table to find that molar mass. 0.9325 moles of HCl. So in this problem, at the end, I'm going to worry about sig figs, but as you're doing the problem, don't worry too much about sig figs for your individual numbers. We want to carry all the digits until we get to the very end. 47.0 grams of sodium hydroxide. Again, moles conversion, 40.0 grams per 1 mole gives us 1.175 moles of sodium hydroxide. So that's a 1. So 1.175 moles of sodium hydroxide. And now, at this point, we want to determine the limiting reactant. So I'm going to compare these two values and figure out which one is the limiting. Now, limiting basically just means which one's going to run out first, right? Which one of these, if you actually did this reaction, is going to run out, and there will be none left. Since it's a 1-to-1 multiple ratio, they're going to be consumed sort of at the same rate. For every one of these, we need one of these. So I can look at these two numbers and I can say, well, if this is 0.9325, that's smaller than this number here. So that tells me that HCl is the limiting reactant. It's going to run out first. Now, in step 2, we're going to use stoichiometry. Stoichiometry. And that basically means we're going to use the multiple ratios to say, well, if this is the number of moles of HCl that I have, how many moles of my product, sodium chloride, am I going to be able to form? A lot of us can probably see that that's just going to be the same number, but let's show the calculation. If you have 0.9325 moles of HCl, and you multiply that by the multiple ratio of 1 mole of sodium chloride for every 1 mole of HCl, you're going to get that same number back, 0.9325 moles of NaCl. So now we know the number of moles, and the last step is just going to be another conversion. So step 3, we're going to convert from moles back into grams. It's going to look like this, 0.9325 moles of NaCl times the molar mass, which is going to be 58.44 grams in every 1 mole. And then we get our answer of 54.497 grams. Now at this stage, that's when we're going to convert to the correct number of sig figs. So in this problem, it tells us round your answer to two significant figures. I can also look at our starting values. Whenever you're trying to decide how many sig figs should you have, always go back to your starting values. 2 sig figs here. My answer should have 2 sig figs. So in fact, we're going to round this, I'll just write it up here, to 54 grams. So that should be my answer, just rounding this to 2 sig figs. We just stay with the 54. And that's it. All right, so in the next video, I'll do a slightly more complicated version, but this is the general gist.